This video will teach you how to use washer method for problems with both horizontal and vertical cross sections. For a problem like this, when you're asked to find the volume of the area between two curves when it's rotated on the x-axis, the first thing you're going to do is graph the equations and then highlight the area, which in this case is going to be the vertical cross sections. And since it's around the x-axis, you want to draw the equations in the other part of that axis, so you're going to be able to better visualize the solid being formed. And each cross section in this case is going to be a washer, since there's a portion in the middle that is hollow. So as for washer method, it's a fairly simple formula. It's simply just going to be volume equals the integral from 0 to x being the spot where the equations intersect, of pi times the outer radius squared, which is that blue equation there, the outer portion of the washer, as you can see, minus the inner radius squared, which is going to be the red equation, which is the inner portion of the washer, times dx, since there are vertical cross sections with a horizontal axis. Now, you're going to plug in 1 for x, since that's where the equations intersect. That's going to be pi times the outer radius squared, which is x squared, minus x squared squared, which is the inner radius, times dx again. And then when you integrate x squared, it becomes x cubed over 3. And then when you integrate x to the 4th, it becomes x to the 5th over 5. And that's, once again, you're going to distribute the pi as well. And that's going to be from the interval of 0 to 1. So when you plug in the interval, it's just going to come out as pi over 3 minus pi over 5, which is 2 pi over 15 units cubed. And that's going to be the volume of your solid formed.
So now we are going to give an example of how to find the volume when the area between two curves is rotated around the y-axis instead of the x-axis, as shown in the previous example. So first, we're going to need to make sure the equations are in terms of x, because we are rotating the area around the y-axis, and the y value will be plugged in later in order to solve. So y equals root x is the same as x equals y squared, and y equals x squared is the same as x equals root y. Now we are going to want to graph the equations on the graph. So this red line represents x equals root y, and I recommend you draw the equation on both sides of the graph because it will help you visualize the example. This green line represents x equals y squared, and these horizontal purple lines represent the horizontal cross sections for the area. So when you rotate the area around the y-axis, these washer shapes will be formed with obviously their horizontal cross sections. Similar to the problems where the area between two curves is rotated around the x-axis, the equation is pretty simple. The volume is equal to the integral of 0 to y, y being the point at which the equations intersect, of pi times the outer radius squared, which was this red equation, minus the green equation, which in this case is the inner radius, and times dy, because there are horizontal cross sections with the vertical axis. Now y for this problem is going to be 1 because that is the y value where the equations intersect. So the new equation is going to be volume equals the integral of 0 to 1 times of pi times the outer radius, which in this situation is root y squared, minus the inner radius equation, which is y squared, and then square that, and times dy again. Root y squared is the same as y, and y squared squared is the same as y to the 4th. You're going to need to integrate after you have this equation. So y integrate, or the antiderivative of y, is y squared over 2, and the antiderivative of y to the 4th is y to the 5th over 5. And you can't forget to bring down the pi. Can't forget about that. And we're going to be evaluating this equation from 0 to 1. So when you plug in the when you plug in the 1 for the y squared over 2, you're going to get 1/2. And when you plug in the 1 for the y to the 5th over 5, you're going to get 1/5. You're going to have to distribute the pi. So you're going to get pi over 2 minus pi over 5, which equals 3 pi over 10. When you plug in the 0, it gives you nothing. So the final volume of the new solid formed is going to be 3 pi over 10 units cubed.
And now you too can solve problems with horizontal and vertical cross sections with the washer method.